Today we're going to be starting Chapter 6. Alright, before we do the slope fields, I have a few differential equations that we're going to solve just to warm ourselves up, since this is related to that. We did differential equations briefly in Chapter 4, but now they're back in a big way. Chapter 6 is going to be all about getting deep into the differential equations. So we'll start here, number 1. First and foremost, the most important thing is to separate variables. If you don't do that, you're in a world of trouble. So we're going to get this dx to the right. I'll knock it off of there. Again, all the y's and dy's have to be together. There are no y's here, but if they were, they'd be on the left. All the x's and dx's have to be on the right. All right, we're going to integrate both sides, just like we did in Chapter 4. The integral of dy, again, is just y. Over here on the right-hand side, though, we have tangent over cosine. I might be able to kind of change that around a little bit. Tangent itself is sine over cosine. So if you think about that, you're really looking at sine of x over cosine squared of x. I'm going to rewrite the problem to look like that. Okay, now I can u sub. We're going to make u cosine of x. Making du negative sine of x dx. I'll go ahead and put a negative on the sine, another negative out front, and this right here that I'm circling becomes the du. Negative is still out there. And now we have 1 over u squared, or u to the negative second. I have to caution you, a lot of people see the 1 over u squared, and we've just come off a big section of natural logs, and they think that this is natural log of u squared, and it's not. Remember, natural log is only used if it's 1 over u, or u to the negative first, just because if you come up by a power, you can't divide by 0. This, you just go up by a power, divide by the new power like we've always done. This is not a natural log problem anymore. When I do come up by a power, I'll end up with a double negative that's going to just turn positive. So it'll just be u to the negative first, or 1 over u plus c. So the answer will be 1 over cosine of x plus c, also known as secant of x. Just a word to the wise, be careful. A lot of people will have this right here, and they're like, okay, plus plus, that's cool. But then when it's u to the negative 1, they're going to write it like this. Cosine of x to the negative first. Except that is the abbreviation for inverse cosine, and you're going to confuse people. Obviously, if I looked at that answer, I'd think you meant inverse cosine, and that's not what you mean. You mean secant. So don't write it like that. Okay, here's the second differential equation. Again, separate variables first. So we'll put the dx on the other side, and now we'll integrate. All right, got my u sub set up. I do need a 32. I have the x to the 7th dx, so I'll give myself a 32 right here, along with a 1/32 out front. And now I have the 32x to the 7th dx that I need to make this du. 1/32, like I said, out front. Still have not integrated yet. And I'm left with 1 over u, which this time around is a natural log. So the answer is going to be y equals, make sure to say your y equals also, because we want a differential equation. If you don't have y equals, you don't have an equals, you don't have an equation. Y equals 1/32 natural log of u plus c. Remember, though, that u is actually 4x to the 8th plus 1. You may be wondering, don't you mean absolute value? And yeah, well, absolute value is always safe. I'm just showing off here. I realize that 4x to the 8th plus 1 can't go negative or 0, so I just curled it just for show. But again, if you have absolute value, that's safe. There's nothing wrong with that either. It's not going to hurt. All right, one more DiffyQ, and then we'll be ready for some slope fields. Number 3 is the exact same question as number 2, except instead of an x to the 7th in the numerator, I made it an x to the 3rd, which changes everything. Now that u sub that I just did in the last question can't be done. I do know that I need to separate variables still. That always happens. But since I can't u sub right away, I have to do something a little bit more drastic when I integrate both sides. And drastic times call for drastic measures, and there's not much more drastic than making it into an arctan, which is what I'm going to attempt to do. I think I can make it look like the arctan formula. I've got the plus 1 already in the denominator. I need this 4x to the 8th to become u squared. So here again, a 3-step u sub. Okay, so I wrote it down. U squared is 4x to the 8th, making u 2x to the 4th when I square root both sides, and du 8x to the 3rd dx. This is going to work because I've got the x to the 3rd. I needed the 8. I'll put a 1/8 out front. Now the 8x to the 3rd dx combines to make the du. Everything else is in place. So the general solution is going to be y equals 1/8 arctan of u plus c. And just remember to put the u back in, and the u is 2x to the 4th. And there's our correct answer to number 3. All right, now that we've practiced up with a few differential equations, we're going to use this differential equation, and we're going to construct what's called a slope field. What a slope field is it's a series of just tiny little line segments through the 9 points, or however many points you're given, and the slope of the line segments is going to be based on the derivative at that location. All right, so let's talk. We have, again, several points to look at. I'm going to start with the point 1, 2. If you take the 1 and 2 and plug them in, remember 1 is the x and 2 would be the y, you're going to end up with the numerator being 2 minus 2, which of course is 0, over 2, which in turn is 0. So what you do is you go to the point 1, 2, and you make a 0 slope, which is horizontal. All right. And then we repeat the process for the other 8 points. I'm just going to try a couple more, and then I'll just fill in the drawing. Let's go right below it to the point 1, 1. You put the 1, 1 in, you get 2 minus 1 over 1. So that's going to be 1 over 1, which of course is 1. So what you do is you go to the point 1, 1, you make the slope look like it's 1, up 1 over 1, little 45-degree angle. It doesn't have to be perfect, but it should be fairly close. All right, let's go just one more place for now. How about negative 1, 2? So here x is negative 1, the y's are 2's. That's going to give you negative 2 minus 2, that's negative 4, over 2. So the slope there will be negative 2. So you make what looks to be a negative 2 slope. Notice that that's steeper looking than the positive 1 was over in quadrant 1. And then you just repeat this process for the other 6 points. I'm going to do that right now. All right, I'm partway through. A couple of these slopes are negative 3's. And a good question is, how do you know if it's negative 2 or negative 3? They're both getting kind of steep. What about negative 4? Should you label for the graders? And usually I do. I'm not going to insult the graders by labeling the zeros and the ones and the negative ones, but if it's, you know, -3 or even -2, sometimes I'll label it next to it just so there's no confusion. To be quite honest with you, the grading rubric the College Board uses simply says relative steepness of the slopes. It doesn't even list the slopes, so as long as your graph is even mildly accurate, you're going to get full credit. Now, there's 3 more that I didn't do yet, but you know what? If you're along the y-axis, that means that x is 0. And I wanted to show this to you in a special case. If x is 0, then this is 2 times 0. It doesn't matter what y is. Your slope's going to be -1 all the time. So it's almost like you get a 3 for 1. And a lot of times on the slope field problems, this happens. And so, you know, it looks like you're doing 9 points, but really you only have to think about 6 of them. So that is the slope field for number 4. Desmos actually has a slope field generator, which I think is kind of cool. So I'm going to go there right now. And this is really cool. Now, obviously, we only did 9 points. But that's the equation that we used. The 2x minus y over y was the differential equation. And you can see all the slope fields. And you can see some patterns forming. You can almost see the slopes curling. You can see what seems to be a slant asymptote. So this will help you realize what the original equation looks like. See, we're given a differential equation, but we don't know what the y equals is. And in my number 4 that I just did, unlike the first 3 differential equations, there's no way to solve it. If we go back to it, and I said, hey, solve this differential equation, you wouldn't be able to do it because there's no way to split the x's and the y's. You wouldn't be able to separate the variables. And we'd be absolutely doomed. So the only way to figure out what the y equals might be is to start doing all these slope fields. And when you get enough of them, the actual answer will weave through, almost like you have a spirit squad, cheerleaders, marching band, and the football team runs through the tunnel. You know, the slope fields are sort of like the tunnel, and then the equation's going to run through it. Even though we can't solve the equation or figure it out, we can kind of piece it together using slope fields. A lot of times in the real world, we try to measure phenomena, you know, in science especially, and we don't have an equation for things that occur naturally, but we can measure the rates at which reactions occur. And remember, rate is a derivative. And we measure a bunch of rates, we get a bunch of little slopes, we make a slope field, and then we can put the equation in just by drawing freehand and figure out what the y equals is. So that's really why we learn slope fields. I'm going to go back to the Desmos slope field that we just made, and I'm going to put these 9 little slope points on there, and you can kind of see that it matches with what we got. Our slope field was just centered at those 9 points. I didn't want to have you do all the rest of them. As you can see, some of them get very steep, but those were our answers. Remember, we had the 0 up there at the point 1, 2. A pair of these ended up being -3 right here and right here. So yeah, it looks pretty good. Our answer is correct, which is always nice to know. Again, it looks like the original graph is going to look something like this. Maybe some sort of a double-branched hyperbola. Interesting.
All right, let's try another slope field, 9 more points. We've got x plus 2y as the derivative. 0, 0 is easy. That's just 0. So super simple there. Let's go over to the point 1, 0. You can see that that's going to be 1 plus 0, so that's 1. -1, 0 would be -1. All right, so the middle is done. Let's go ahead and step up to the point 0, 1. We'll stay right along the y-axis. X will be 0 each time. 0, 1 is going to give us a slope of 2. Just have to make that look a little bit steeper. All right, that looks pretty good. Let's see, 1, 1 would be 1 plus 2. That's going to be a slope of 3. I'm going to label that one, just so that the graders know for sure that I know that it's 3. And if we try -1, 1 up in quadrant 2, that's going to be -1 plus 2. That's going to be positive 1. Let's make it look like it's 45 degrees. Remember, they grade these based on the relative steepness of the slope, so you don't have to be perfect, just close. All right, a couple more points, 3 more points actually to try. Let's start with the 0. X is 0, y is negative 1. That's going to be negative 2. Okay, negative 2 right there. Let's go over to 1, negative 1. That's going to be 1 minus 2, that's negative 1. So again, a little 45-degree slant. And then finally, negative 1, negative 1 will be negative 3. That's pretty steep. I'm going to label that as well. What I like a lot about some of these slip fields is that you can see patterns. You know, down here at the bottom, you've got negative 3, negative 2, negative 1. Negative 1, 0, 1, you're going up. 1, 2, 3. So that just gives me a little extra confidence. All right, so that's number 5. And the last two, number 6 and number 7, are multiple choice. Let's try them out. Here's 6. You're given a slope field, and you have to identify the differential equation that matches up with it. Okay. Well, first of all, I look at choice A, and I know right away that it's incorrect. And the reason I say that is because it doesn't have any y's in it. And y matters. Because as you head up or as you head down, you can see the slopes changing. If y didn't matter, then why are the slopes changing? The equation's got to have a y in it somehow, so it can't be A. A is out. So we're down to B, C, or D. The other one that seems a little suspect is C. And the reason I say that is because both of the powers are even. So no matter what you put in there, other than 0, of course, you'd have positive divided by positive, which would have to be positive. But clearly there are negative slopes. In fact, the 3 that I circled previously are all negative. So that can't be it. So we're down to either B or D. And I would go to some unusual quadrant to break the tie. I would not stay in quadrant 1 where everything's positive. Let's try going to quadrant 4. That probably will tell the tale. If you go down to the lower right, and let's try a point down there like, say, 1, negative 1 right here. 1, negative 1, where it looks like the slope appears to be positive 1 or something similar to that. Let's try it out. 1, negative 1, 1, negative 1. You can see that the correct answer here is going to be D. That will break the tie because this is 1 over 1. The negative gets squared. Here, it's going to be negative 1. And that's not what I'm seeing. So that's out. And the correct answer is D. And you could try any other point. It doesn't necessarily have to be the one that I picked, but it's a process of elimination. And you shouldn't feel bad about that. That's how slope field multiple choice questions are designed to be answered. Speaking of which, here's one more. Number 7, and that'll be it. Which of the following DiffyQs corresponds with the slope field shown? All right. Well, you know what's kind of interesting is a lot of this looks very similar. In fact, I mean, look at this action. As you head across from left to right, there's no change. Same thing here, there's no change. As I go from left to right, I don't see any changes in any of these rows, which means the x doesn't seem to matter. And if the x doesn't matter, there's only one answer that can possibly be right, and that's choice B, because it doesn't have any x's in it. Now, I feel like I went too fast, even though I got it right. But you could try some points. You know, I mean, try 0, 0, for example. 0, 0 looks like a slope of negative 1, and it would work right there. You'd have 0 minus 1. 0, 0 in choice A and C would give you 0. It should have been flat. It's not. So if it makes you feel better, those would be out. Now, D does give you the right slope for the origin, so maybe we'll go somewhere else, maybe off the beaten path. How about sliding over a few places? Let's go to 2, 0. Let's come over here. I could really pick anything, but I thought, yeah, why not? You plug in a 2, 0. I guess you can't really plug the 0 in. But you can see that's 4 minus 1. That's positive 3, and there's no way that's positive 3. That's negative 1, so that's out. And of course, if you tried into choice B, the correct answer, you try in 2, 0. The 2 doesn't get to play because it's an X. The 0 becomes the Y, and sure enough, negative 1. Everything along the x-axis is negative 1 for that reason. So 7 is B, again, by process of elimination. And that concludes our lesson on slope fields. All right, we'll see you next time for regular differential equations, which will be a 2-day section. Until then, take it easy.